Hi guys, Ms. Malik here. Today we're doing exercise 4B from your essential textbook, and it's a bit of a revision of quadratic functions, in particular how to sketch them using different methods. So the first thing we want to be able to do is to use the quadratic formula to find x-axis intercepts. Here we're asked to sketch the graph of f of x, which is negative 3x squared minus 12x minus 7, by using the quadratic formula to sketch the x-axis intercepts. It's a good idea to list the things you need in order to draw your graph. X-axis intercepts, y-axis intercept, and the turning point. Let's first deal with those x-axis intercepts. The quadratic formula is negative b plus or minus root b squared minus 4ac over 2a. There it is there. We get a, b and c from the equation, and it's in general form ax squared plus bx plus c. A is therefore negative 3, B is therefore negative 12, and C is therefore negative 7. We then just substitute those values into our quadratic equation. Negative 12, note the double negative there because it's minus B, and B is minus 12. So minus 12 plus or minus root negative 12 squared minus 4 times negative 3 times negative 7 over 2 times negative 3. Let's simplify that. 12 plus or minus root 144 minus 84 over negative 6. We end up with 12 plus or minus 2 root 15 over negative 6. And finally, 6 plus or minus root 15 on negative 3. Notice that I was only able to divide by 2 because 12 is a multiple of 2, 2 root 15 is a multiple of 2, and negative 6. 2 goes into that as well. 2 has to go into every one of those three terms in order for us to divide by 2. So the x-axis intercepts are at 6 plus or minus root 15 on negative 3. Done. Let's move on and see what we can do next. Let's look at the y-axis intercept. The y-axis intercept is where x is 0. So let's just substitute 0 for x. F of 0 equals negative 3 times 0 squared minus 12 times 0 minus 7. And therefore f of 0 equals negative 7. So the y-intercept is negative 7. Done. We've only got one more thing to go, and that is the turning point. We have a formula for finding out the turning point, and that is that the axis of symmetry for the x value is negative b over 2a. So, negative 12 over 2 times negative 3. And don't forget that negative sign in front as well. So we end up with x being negative 2. Now, when we substitute negative 2 for x, we end up with 5. This is an important step. When we find x being negative 2, that only tells us our x value for the turning point. We have to find the y value as well. So by substituting x in, we find what y would equal. So our turning point is at negative 2, 5. Done. Looks like we've got all the things we need in order to draw the graph. Let's draw the graph. Here it is here. The x-axis intercepts at 6 plus root 15 over minus 3 and 6 minus root 15 over negative 3. Now, a lot of people would mix those two up and put them in the opposite places. 6 plus root 15 over minus 3, it's got a plus there, so it seems that that would be the larger value. It seems that that should be over on this one. No, it shouldn't. Let's divide by negative 3. 6 divided by negative 3 is negative 2. So that's negative 2 plus root 15 over negative 3. So negative 2 minus root 15 on 3 is that point there, or that bit there. Over here we have 6 over negative 3 being negative 2. Negative root 15 over negative 3 is positive root 15. So that would be negative 2 plus root 15. That's why that one goes at a higher value. Let's put the y-intercept in. There it is down there at negative 7. And finally the turning point up there at negative 2, 5. And there you have it. there's our graph. We now look at another question, which is to complete the square in order to sketch a graph. So we're going to solve 2x squared minus 4x minus 5 equals 0 by expressing it in the form of y equals a x plus h squared plus k. That's turning point form. Use this to help you sketch the graph of f of x equals 2x squared minus 4x minus 5. So let's list the things we need: x-axis intercepts, y-axis intercept, and turning point. Let's start with the x-axis intercepts. So it's told me we want to put it into turning point form. So we're going to do that first, and we're going to use that in order to find the x-intercepts. So f of x equals 2x squared minus 4x minus 5. Let's take the 2 out, because when we put it in turning point form, we can't have anything in front of the x. In front of the x has to be a 1. So take the 2 out to get x squared minus 2x minus 5 over 2. There's a fraction there, and it looks a little messy, but it's still fine. Let's now go about completing the square. We want to get it so that we have x plus or minus something squared. So x squared minus 2x plus half of minus 2 squared. Half of minus 2 is minus 1, and squared is just 1. So we get x squared minus 2x plus 1. We then need to subtract that 1. We can't just add on a 1 out of nowhere. By subtracting it again, it means we've actually added nothing. Plus 1 minus 1 is 0. We've added nothing onto this equation. We're just putting it in a different form. So we subtract the 1, and then we have to subtract the 5 over 2. Notice how I've got these square brackets at the ends there. That's because I have to know that I've taken a 2 out. So I've taken a 2 out of that negative 5 on 2. I need to keep the brackets there. I can't just halve it all of a sudden for nothing. We then end up with, when we complete the square, we have x minus 1 squared there. So 2, square bracket open, x minus 1 squared minus 7 on 2. Notice how I've made that negative 1, negative 2 on 2, and then I've just subtracted the fractions from one another. I then want to get rid of the square brackets. If I take the square brackets away, it means that I'm multiplying x minus 1 squared by 2, which is correct, but then I wouldn't be multiplying negative 7 on 2 by 2. So I need to actually do that. So multiplying 2 by negative 7 on 2, I get negative 14 on 2, which is negative 7. I can then get rid of the brackets, leaving me with f of x equals 2, open brackets, x minus 1 squared minus 7. That's now in turning point form. Let's solve for x to find the x-axis intercepts. So I'm going to equate that to 0. I subtract 7, I add 7 on both sides. I divide by 2 on both sides. I square root both sides, remembering it's plus or minus. And then finally I add 1 on both sides, meaning that my x-intercepts are at plus or minus root 7 on 2 plus 1. There's my x-axis intercepts. Done. Let's move on from there and see what else we need to do. Let's go to the turning point form now. The turning point. So we've got our equation in turning point form. So this is very easy now. We know that the turning point is just the negative of whatever that term is there, h, and k. So the turning point is at 1, negative 7. Done. What about the y-intercept? That's easy. I just need to make x 0 because the y-intercept exists when x is 0. So f of 0 equals 2 times 0 minus 1 squared minus 7. So f of 0 equals negative 5. We could have just got that from the original equation as well. The y-intercept is at negative 5. Done. It's a good idea to find your x-intercepts from the turning point form if you've already got it like that. Even if the question doesn't ask you to put it into turning point form, if you want to do that in order to find the turning point, find the axis intercepts that way too. We now know that we've got our turning point at 1 and negative 7. Let's put it in. we have our y-intercept at -5. Let's put it in. And then we have our x-intercepts at plus and minus root 7 on 2 plus 1. There's negative root 7 on 2 plus 1, and there's positive root 7 on 2 plus 1. Be careful when you put those in. In this case, root 7 over 2 is less than 1. So when we add 1 on, we're still in the negative zone of the x-axis. Sometimes you might not be. You might have a negative root and then add something that actually takes it into the positive zone. Watch out for that. And of course I write the equation of my graph onto the graph there. And that's it. That's exercise 4B complete.